Okay, so we are continuing last class's storyline. So types of counting, part 2. So to recap, you're a secret agent in London trying to hunt down a mathematician turned assassin, codenamed Adder. Last time you saved yourself from an attack from Adder. However, your boss, me, isn't happy to see that you couldn't track Adder down. So now it's time to finish the job. So, um, okay. So this time we are, so we will learn how to do handshake problems. So handshakes. You will attend a meeting with some of your fellow secret agents to discuss the situation with Adder. So there's Agent Ruth, Agent Kayang, me, Agent Angela, and you. So everybody shakes hands with everybody else. So how many handshakes occur? So you all might know how to solve this, but to recap how to do it, or to go over how to do it. So Agent Ruth would shake hands with everybody except herself because nobody shakes hands with themselves. So Agent Ruth would give 4 handshakes to Agent Kayang, me, Angela, and you. So 4 people, and then everyone else shakes hands, and then Kayang would shake hands with 3 people because she already shook hands with Ruth. So that would be me, Angela, and you. So that would be 3 handshakes, and then 2 from me, and 1 from Angela. So 4 plus 3 plus 2 plus 1 is 10 handshakes. So that means, and this pattern of 4, 3, 2, 1 continues, right? So a formula for this is you would find, okay, a formula for this is if there are n people in a room and everybody shakes hands with everybody else, then n times n minus 1 divided by 2 handshakes will occur. And you might also know that this formula is also the formula for the sum of the first n numbers. So for example, if 10 people, or let's go with the smaller number. If 7 people were in a group and they wanted to shake hands, what we would do is essentially add the first 7 numbers, and then that would be 7 plus, or that we would add the first 7, we would add the first n minus 1 numbers, right? So if we had 7 people, that would be 6 plus 5 plus 4 plus 3 plus 2 plus 1, which is 21 handshakes, right? So if you have n people, you would add the first n minus 1 numbers or integers. I misspoke earlier. So yeah, everybody in the chat who is saying 21, you are correct. So however, you realize there is a problem. So as you know earlier, there were 10 handshakes, but you knew ahead of time that there were supposed to be 15 handshakes, not 10. So if you know that 15 handshakes occurred in a room where everybody else shook hands with everybody else, how many people would be in that room? I don't know if you're being intentionally extremely off the mark for the answer, but if 15 handshakes occurred, there would be fewer than 15 people. Okay, so a lot of people put 6 in the chat, and that is correct. So if there were 6 people, we would add together the first 5 numbers, 5 integers, 5 positive integers. So 5 plus 4 plus 3 plus 2 plus 1, which would also be 5 times, or it would be, so there would be 15 handshakes from that, right? So that would mean that 6 people would have been in the room. So were there 6 people in the room just now? No, there were only 5 people in that room. So we will be going on to another type of problem.
So at the meeting, everyone takes a seat around the table. How many different seating arrangements are there? So there are 5 possible seats. So the total number of seating arrangements, you would think that it would be 5 factorial, but it actually isn't. Because this is a table, each seat can be arranged, each seating arrangement can be rotated to form an equivalent seating arrangement that is identical. So as you can see in the picture, but even though they aren't technically in the same seat, it's like the same since you just rotated it. So this means that using 5 factorial is overcounting. Since each arrangement can be rotated to form 5 different arrangements, we can divide 120 by 5 to get the actual number of distinct arrangements. So the actual number of seating arrangements is 24. So this is the formula for it. For a table with n people, there will be n factorial over n, which is the same as n minus 1 factorial seating arrangements. And after you take your seat, you realize somebody is missing. Agent Ishani says, "Hey y'all, where's Yolanda?" And I say, "I don't know." And Agent Ishani says, "She was just here the other day. Where is she?" Because Ishani is getting upset, you decide to tune out the conversation and do some math problems in your head. The first one is, if there are 9 people in a room who all shakes hand, how many handshakes will occur? Yeah, so everyone's saying 36, and that's right. The next one is, 8 people take a seat around a table. How many seating arrangements are there? Yeah, so the answer would be 7 factorial, which is 5,040.
Okay,
When you
sorry. When you tune back in, you discover the meeting has actually ended and you've been assigned to go on another mission. So at least you got to get some sleep. So your destination is a local sports stadium where a big soccer tournament is going on. So the prize is this $900,000 necklace that is shown on the right. As you can see, it looks very expensive. And this is also in addition to like the $300,000 trophy that they'll also be getting, but that's besides the point. So this is the big stadium that you are at. So at the stadium, there are 7 teams playing against one another. If each team plays every other team once, how many games should occur? So this is really similar to your handshakes problem, except it's not handshakes this time, it's games. So use the equation that we got from that. Okay, so I am seeing a lot of answers that say 21, and you are correct. So because there are 7 teams playing, the first team would play 6, and then the next would play 5, 4, so on. So we would be adding the first 7 integers together. And as you know from earlier, the sum of the first n minus 1 integers would be n times n minus 1 divided by 2, which is 7 times 6 divided by 2, which is 42 divided by 2, which is just 21. So 21 games should occur. Okay, and another problem. So, okay, so your mission, yeah, basically you're there to watch the match and make sure that this doesn't get stolen. So the necklace is made from a silver chain, and in 5 different objects and 5 different objects are strung through it. So as you can see, there's the blue soccer ball, there's the brownish grayish one, there's the yellow one, there's the reddish one, and then there's that middle one, the little trophy thing. So if you took 5 objects and rearranged them on the necklace, how many arrangements would be possible? Okay, so think through it logically, which is bad advice, but because it's not specific. But the order would matter. So for example, if I change, like there's not just one way to have that necklace. If you were able to take off the beads and rearrange them, there'd be multiple ways. So if I took that middle trophy and I put it next on the left side of that brownish grayish one, right? That would be a completely different combination of necklaces, of beads, because it would form a different necklace, right? So that wouldn't be same as this one. Okay, so I'm seeing some answers. I'll give you, or actually no, I will explain it. So you'd want to use the table problem strategy, except there's one more thing you have to think about. And you may or may not know what you want to think about, but yeah, it's the fact that you can flip the necklace and it would still be the same necklace, right? So there would be, so we would want to divide by 2 after we multiply out the number of ways. So there are 5 objects, so there are 120 ways to arrange 5 objects, but like the table problem, you would need to divide by 5 to account for rotation. So you have 24 ways. And because your necklace can be flipped, you would need to divide by 2. So you would have 12 distinct arrangements. So the reason we divide by 5 is because for each, so for this, there would be 5 ways to rotate it, so that by rotating beads, I'm assuming you mean the whole necklace. But basically, the reason that you divide by 5 is because there are 5 objects here, as you can see. So there are 5 ways to rotate this. So one of the objects is at the center or the bottom or whatever. But it would still be the same necklace because you could rotate it to get that original, right? So yeah. So yeah, everybody put 24. Probably because you forgot to divide by 2 because it is a necklace or bracelet or whatever, so it can be flipped. So yeah, these necklaces would be the same because you could flip one to get the other. So the formula for this, or the formula to arrange n beads on a bracelet / necklace, is n minus 1 factorial divided by 2. I don't know what you are trying to say. Okay. So after watching the game, you come back and discover that the necklace is gone. So you know that someone had to steal that $900,000 prize, right? It was someone. And it's very terrible, but there's some good and there's some bad news. So the good news is you saw the license plate of whoever did it. And the bad news is you don't know the exact number of the license plate.
So the license plate was made up of 3 Qs, 2 Vs, and 1 N, but you don't know what order they're arranged in. So how many possible license plates could there be? Yeah, so you guys are getting the right answer. It's 60. So basically what you would do is 6 factorial divided by 3 factorial times 2 factorial.
Yeah, and just to clarify the reason for the 3 factorial and 2 factorial, it's because there are 3 Qs and there are 2 Vs. So if you have any repeated object or variable or whatever, then you would divide by that factorial.
And so some bystander came up to you and says that they also saw the license plate number, and they give you some clues. So the first person says that the license plate started with a Q. The second person said that the V's were separated by one letter. The third person says two of the Q's were separated by three letters. And the last person says that the N was somewhere in the first three letters. So based on these clues, what was the license plate number?
Okay, wait, just to go back. There were 6 letters, 3 Q's, 2 V's, 1 N.
Most of you guys are getting it right, except there's 3 Q's. Yeah, so it's Q, V, N, V, Q, Q.
Okay, yeah. Just to explain how you would get that, even though most of you did get it. So we know Q is at the beginning, and then the V's were separated by one letter. So V blank V, V blank V, or V blank V here, right? So 2 of the Q's were separated by 3 letters. So the one way for that to be is for the Q to be here and the Q to be here, but that didn't happen, because if that were the case, right, it didn't happen, right? So we know that the 2 of the Q's were separated by 3 letters, and the N was somewhere here or here, and the V's were separated by 1 letter, so it was probably that N, right? So V and V, and then obviously that last Q would go because we need to place it.
Yeah, so now it's time to go on a car chase. You're driving down I-65 going 60 miles an hour when you spot the car. You hit the gas pedal and the speedometer jumps to 90 miles per hour. The chase is on. You follow the car off the highway and come to a junction. The car is out of sight, so you think you've lost it, but Agent Ruth, who is on the helicopter above you, radios a coded message. How many ways can you put 5 people into 6 seats around a table? Yeah, so the answer is 120 because it's 5 factorial. So you speed down 120th Street. Now you hear Ruth yelling over the radio, I flipped a coin 5 times in a row. How many ways can I toss 2 heads? Yeah, so the answer is 10.
Yeah, so it's just 5 choose 2, which most of you did to get 10. So 5 times 4 divided by 2 would be equal to 10.
The car is in sight, and even better, they turn into an alleyway with no exit. You follow the car into the alleyway, and now the car is trapped. This is so satisfying to you that you pull out of your phone and take a video of it. Then you hop out of your car and knock on the window of the car in front of you. You peep into the car and it's Agent Yolanda. What are you doing? You yelled. Are you at her? Nope, she says. Then 3 more cars appear behind you. At first, you were really scared, then you realize it's actually the police and they were wanting to arrest you for speeding. If the speed limit was 55 miles per hour and the speeding fine is 15 per mile over the limit, what is your speeding ticket fine?
They're going 90, right?
Yeah. Yeah, so the answer is 525 because it's 90 minus 55. That's how you get the amount above the speed limit you are times 15 is 525.
You tell
You
I
go.
can, yeah, okay. So you tell the police how much your speeding ticket is before they even pull out a calculator. And they're so impressed at your math skills, they forget to arrest you. So that's when you tell them, actually, you see that orange car up ahead? That's the person who just stole a $900,000 necklace. So maybe you should arrest them first. The police give you a ticket anyways, and they go arrest Yolanda for stealing the soccer prize. So you go back to headquarters, and once again you find yourself in a meeting, but this time Kayang and Ruth seem to have gotten into an argument, so they refuse to sit next to each other. So how many ways are there to sit down now? There are 5 people present at a table, and okay, yeah, sorry, you saw that, but yeah, okay. I will change the prompt. If there's 6 people sitting down, and Kayang and Ruth are amongst them, and they don't want to sit next to each other, how many ways are there for them to sit down? Just change it on screen. Okay, so there are a variety of answers. I'll give you all another minute to answer. So if there are 6 people present and they want to sit around a table, but 2 of them do not want to sit next to each other, how many ways are there for them to sit down? Yeah, I changed the problem, so it's 6 people. Yeah, she got arrested. It's you, then me, and then Kayang Ruth, and then Amy, and then Agent Angela. Except it's not really, because there are only 5 people at the table. Okay, so I am seeing a lot of answers, so I will explain it. So if we have 6 people at a table, right? And 2 of them don't want to sit next to each other, we treat them as, we first want to find out how many ways 6 people could sit at a table. So 6 people would become 5 factorial ways to sit at a table, which is equal to 120. So there are 120 total ways, right? And then we want to, and then we are now going to use complementary counting, right? So we'd find the number of ways for Kayang and Ruth to sit next to each other. So if they were sitting around a table, Kayang could either sit on the left or the right of Ruth, right? So there are 2 ways to arrange Kayang and Ruth, so they're sitting next to each other in one unit, multiplied by the number of ways to organize all the other 4 people around the table. So that would be 2 multiplied by 4 factorial ways for them to sit around, right? And that would be equal to, so 4 times 8 times 2, 24, 48 ways, right? And yeah, we would do 120 minus 48, which is going to be equal to 72. So 72 would be the answer. So yeah, there would be 72 ways for 6 people to sit down. However, there are in reality only 5. So there are 24. Okay, so you guys hear over the news that the soccer necklace thief has been caught. This makes Kayang start arguing with Ruth again. Kayang says Yolanda definitely is not Eder, but Ruth says she is. Yolanda is a dirty traitor. Kayang said just because she stole a gazillion-dollar necklace doesn't mean she's Eder, but Ruth thinks it does. So do you think Yolanda is Eder, or was Yolanda just being a thief? So do you think Yolanda is Eder? Just answer that in the chat.
I have to go.
Okay, yeah. Feel
I'll
free
watch
to
the video.
Okay. The comments are very chaotic, but I will assume that they mean you think Yolanda is Adder. And what would Yolanda's motive have been for stealing the necklace? Was it just money? Okay. Okay. And now we have a Kahoot. Okay, sorry, this is taking a sec. Okay, would you all like team mode or would you like classic mode?
Individual, please.
Okay. Also, I will make it so you can get here. Some of you want to, okay, everybody in the chat, just one time. Put team or individual for whichever you'd like, just so like we have a consensus. Okay, I think team is winning out right now. So, okay, wait.
What do we do?
Just join the Kahoot with the code, and then it'll put you in teams afterwards, presumably. I don't think there's a mode for letting you choose your team. Okay, I'm not sure it's actually working out then. Or it will work
Can we
out.
just start and just see how it works?
Yeah, okay. Yeah, I don't think it's gonna work. Yeah. Probably would have been a better idea to do individually. Yeah. Okay. 12 people are at a party and each person shakes hands with every other person. How many handshakes occurred?
Blue.
Do you all want to restart this as individual?
I mean, we know the first question, so it's kind of.
Just do it.
Okay, yeah. Okay, wait, hold up. Okay, so I'm like 90% sure there are more of you. Yeah, there should be at least 10 of you. Or there should be 10 of you. So 3 of you, yeah, just join. Say another question. Okay, yeah, so it's 66. So essentially you would do, okay, so the first person would shake 11 hands. So you're finding the sum of the first 11 positive integers, which is just 12 times 11 divided by 2, which is just 6 times 11, or 66. So good job, Aryan, for being top. Okay, there are 10 teams in a tournament, and every team plays every other team twice. How many matches occur? This would be different than if they played each other once.
It's 110.
Okay, so it's 90. Some of you put
Yeah.
45. Yeah, some of you put 45. Remember it said every team plays every other team twice. So when you're finding, so you'd okay, if they were to play each other once, you would find that the first team plays 9 games, the second plays 8 that aren't already counted, and so on. So that'd be the sum of the first 9 integers. So that would be 9 plus 1, or 10 times 9 divided by 2, which is 45. However, they play each other twice, so we multiply it by 2, and you would get 9. How many ways are there to organize 9 identical gloves in 3 different bins? So this is sticks and stone. Okay, yeah. So the answer is 55. So there would be 9, 10, 11. Okay, so if there are 3 different bins, there would be 2 dividers, right? 2 sticks, right? So there would be 11 objects. So if we were doing sticks and stones, there would be 11 objects. And we would have to do 11 choose 2. Okay, so okay, I'm assuming a lot of you all do not remember sticks and stones. So do you want me to explain that, or do you just want me to? Okay, yeah. Some of you are saying yes, so I'll explain. So sticks and stones is where you count the number of objects plus the number of dividers, right? So dividers would okay, so plus the number of dividers. So in this case, there would be 3 bins. So there would be, yeah, it's stars and bars or sticks and stones. It's called stuff, right? I learned it as sticks and stones, but yeah, stars and bars is also another name. So you would sum the number of objects and the number of dividers. So there would be 3 bins in this case. So in order to divide any number of stuff into 3 bins or into 3 parts, you would have 2 sticks, right? So for example, think of a rectangle. If you were to divide that into 3 parts, you would need 2 lines, right? If you would need 2 lines, right? So you would have 1 less than the number of actual containers you're putting them in as the number of dividers. So you would add that to the number of objects, and you would essentially just be doing that choose and then the number of objects that there are. So in this case, there would be 11 objects plus dividers, which would be, there would be 9 plus 2. Choose, and then there would be 9 gloves. So it would be 11 choose 9 or 11 choose 2. And that would just be 11 times 10 divided by 2 or 55. So hopefully that explains it. Good job, Harshies. Okay, how many ways are there to organize 9 identical gloves into 3 different bins if each bin needs at least 1 glove?
Except for 55.
And it is not 55. No, it's not. This one is saying if each bin needs at least 1 glove, right? Okay, yeah. So if each bin needs at least 1 glove, then we can remove 3 of the items, 3 of the 9 gloves, right? Because we already know 1 of those would go into each box. And then now we're just dividing the rest of them. So it'd be 6 plus 2, choose 6, or 6 plus 2, choose 2, which is 6 times, yeah, which, okay, wait, no. So it would be, sorry, I forgot to add objects plus dividers. So it would be 6 plus 2, which is 8. So 8 choose 2 or 8 choose 6, which is equal to 8 times 7 divided by 2 or 28. Good job to the people who got it. How many ways are there to organize 9 identical gloves into 3 different bins if each bin needs at least 2 gloves? Okay, yeah, so the answer is 10. So we know that 6 of the gloves will have to be put in already. So there will be 3 gloves for us to sort. So 3 plus 2 dividers, which is 5, choose 3. So 5 times 4 divided by 2, which is just equal to 10. So 10 should be the answer. Okay, Anita put 6 different beads on a bracelet. How many bead arrangements are there? So remember when we did it, we had to divide to account for flipping and rotating. So if she has 6 different beads, she would do 6 factorial, because that's the number of ways to organize 6 stuff. And then you divide by 6 ways to rotate it. So you get 5 factorial, which is 120 ways to arrange the objects. However, you also have to divide by 2, since there are 2 ways to flip it. So because you can flip it, right? So there are 2 ways that seem unique but really aren't. Yeah, so it's 60. Okay. How many paths are there from A to B if you can only move down and right? So remember, you could use combinations, factorials, that stuff, or you could use the numbering thing where you number the top row with ones, or like whichever row is between the starting point and the ending point, or that touches the starting point with ones, and then you add them. Right. Okay. So okay, the answer would be 10. So so this is what we had, right? So you'd number 1 1 1 and then 1 1, and then you would add this 1 and this 1 together and you get 2, and then you'd add this 2 and this 1 together to get 3. You'd add this 2 and this 1 together to get 3. You'd add these together to get 6. You'd add 3 and 1 together to get 4, and you would get 10, right? You could also use like 5 ways. You would have to arrange 2 downs and 3 acrosses, or 3 rights, in order to make that, right? So it would just be 5 factorial divided by 2 factorial divided by 3 factorial. Either way, you would get 10. Okay, how many paths are there from A to B if you can only move down and right? So remember, in this case, the numbering, the edges that the starting point A would touch with ones and then adding together would be the easiest way to do it. Okay, don't be rude in the chat to each other. Okay, so the answer is 12. So again, we would number the sides that A touches with ones for the vertices. So these two ones touch or connect to this vertex. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4 for this. So there would be 4 ways to get there. And then we would only have one way to get to these from a point. So you would get 2 for these vertices. You get 5 here because 2 plus 3, and then 7 here because 5 plus 2, then 5 here, and then 12 because 5 plus 7. Okay, how many paths are there from A to B if you can only move to the right? So by only moving to the right, you probably already know, but you'd have to go this way or this way. Okay, yeah, it is 13. So basically, since a lot of you got this incorrect, I will explain it. So we'd use the same numbering method, right? So we know we have to go in this direction. So there would be one way to get to each of these vertices because you'd have to go right. So 1 plus 1 would be 2, so there would be 2 ways to get to this vertex. There would be 3 ways here because 2 plus 1, 3 ways to get here, 4 ways to get here, and then you'd only be able to get here 3 ways because you can't get here from the top left, right? There's 3 ways to get here because you can only get here from this direction. And then 6, and then 7, and then 7 plus 6 is 13. So there would be 13 ways for you to get from A to B. Good job, Aryan, for remaining in the lead. So 3 coins are flipped, one after another. How many different combinations of heads and tails are possible? Okay, yeah. By combinations, it really meant permutations. So like how many ways could you order them, right? So you'd have 2 factorial, it's not 2 factorial. You'd have 2 raised to the 3rd power because there are 3 coins that are being flipped, and there are only 2 ways you can have for whatever your coin flip is, right? You can only have heads or tails for each of those coin flips. So for the first one, you have 2 ways, second one 2 ways, third way 2 ways. So you do 2 times 2 times 2, which is 2 to the 3rd, which is also 8. So 8 is your answer. This is probably going to be our second last question, maybe. Calculate 5, choose 4. So if you had 5 objects, how many ways could you choose?
Can't you just skip?
Yeah. Okay, yeah. So it's 5. You all except one person got it. Yeah. How many 3-letter sequences are there which do not have the letter Z? You can use a calculator for this one.
Right. I mean, like, it's kind of obvious, so.
Yeah. Okay, yeah. So it'd be 25 to the 3rd because there are 26 letters and you're just removing 1, so 25. And if you're raising anything that ends in a 5 to any power, it will end in a 5. So it is the bottom left one. How many 3-digit sequences have 2 digits that sum to 18?
Wait, how are any of those answers?
Yeah. Well, actually, no. They could be correct because it's not saying any specific 2 digits have to add to 18. It's saying any 2 digits. I don't think that makes sense, but
This is just weird.
yeah. Okay, so basically, to have 2 digits sum to 18, you would need to have 2 digits that are 9. So say the first 2 digits are 9, then that last digit it could be 0 through 8, right? We're going to count the 999 at the end. So 0 to 8 is going to be 9 ways. And then if we had 9 as the first and last digit, 0 to 8 for the middle number, and then second last digits, if we had 9 for those 8, there would be 9 ways to get the first number, right? So we'd have 27, and then we'd add the 999, which is 1 way, and we'd get 28. Okay, this is actually going to be our last. Okay, so what is 4 factorial plus 5 factorial? That whole thing divided by 4 factorial.
Just skip.
Yeah, I mean, yeah. Okay, so 4 factorial divided by 4 factorial plus 5 factorial divided by 4 factorial is just equal to that. So you'd get 1 plus 5, which is just 6. Okay, I don't see an option to end this. So I shall just skip for all of these. If you manage to get a correct answer in, I'd honestly be astonished. So like, yeah. You can try to get the answer correct, but I doubt you would. Oof.
I got one of the last ones correct for guessing.
Oh, yeah. That is you had to be quick, or maybe my internet was slow, but good job. Yeah. Okay, so good job to Aryan, Aiden, and Harsh for being the top 3, and good job to William and whoever he was. Yeah, good job. Yeah, you can feel free to leave now. I shall stop recording.